Zoom recording. Okay, so welcome friends to your July 28th free GMAT prep hour. My name is Reed Arnold. It is July 28th, and today we are going to be twitching the GMAT. Okay, this is something I tried before, but unfortunately I messed up the recording. I'm going to be especially diligent of not doing that tonight. Just a few things up front. A, you can come to one of our classes for free. You can always come to a online or in-person GMAT class. Show up, take 11% of the course, see if you like it, see if you like the teacher, if you guys vibe. It's a good introduction to what we do. So if you're curious about what we offer, go take a class. You can also try our interactive on-demand course, a video course with its own study schedule printed up for you. You can try that as well for free. Okay. And we often have seminars like this, free GMAT prep hours, other free events in certain cities around the country, so be on the lookout for such things. Today we are going to twitch the GMAT. Okay, what I mean by that, if anyone knows what Twitch is a video game thing, I think, where basically people watch other people play video games and kind of talk about the experience, talk about what they think. It can be single player or multiplayer as far as I understand it. But the idea that a few of my other teachers came up with it actually when I was thinking about like, how can I do, what should I do on a GMAT prep hour? Some of them suggested, well, why don't you take the GMAT? Why don't you just live stream yourself taking the GMAT, talking aloud, explaining what you're doing and what you're thinking and whatnot. Let them see what it looks like when someone who really knows the test does the test. And so I actually did this in May for the first time and again, messed up the recording. But the feedback from the students in that group is that I should definitely do it again. They thought it was very valuable. And so I've been waiting for another opportunity to get this thing recorded. So that is what I'm going to do tonight. Okay, you're going to watch me take a GMAT live. Am I nervous? Yes, even though I've done it before. Okay, so just a few thoughts up front about what this is going to look like. I will be writing with my mouse. I have a little annotation tool like this. Okay, yada yada. It's pretty ugly, you know, my numbers are not going to be pretty. My handwriting is going to be very sloppy, but I do want you to kind of see what kind of work I would do. This also means it's going to be slower and less organized. But even still, I will try to keep GMAT pace, even though I am, you know, slightly handicapping myself by using this tool for note taking. I want you all to see my notes. I think that's more valuable than using pad and paper and just talking. So, even though I'm doing that, I am going to keep pace as best as I can, okay? There will be times, since I teach this, there will be times where I've seen a question before. I will try do my best. I will announce it so you know that this is not my first exposure to this question. But I will let you know if I think I could have gotten this question right without seeing it before. I have a pretty good sense of that, having again done this for 5-6 years now. I will definitely make mistakes. I will make so many mistakes. Okay, that's great news for you. One of the things someone asked about nerves. One of the reasons I think this is a good idea and why I want you all to see this is because there's a pervasive myth that you have to get a lot of questions right to get a good score. And the GMAT's a very different test. I plan on missing 10 to 14 questions of the 31 that I see tonight. You're going to get your butt kicked even if you master the test. And I'm going to struggle and I'm going to be confused and I'm going to be flustered. That's okay. I'm going to talk out loud as I do this. I'm also going to try to give like big GMAT insights as they come if I notice them. I will probably not read out loud because I find when I read out loud, I don't think very much. I'm just reading. And so that's not very useful. So I will not read, but I will think out loud and tell you big GMAT things that are coming across. And I will be taking the test of myself. That means that I am going to be trying on this. I'm going to try to get as high a score as possible. So that means we're going to see some of the hardest questions the test throws at us. And that means I do some questions really, really quickly that you're like, what did he just, you know, and it's okay. You don't have to get every type of question. It's just my experience that is helping me in that regard. Okay, I do this for money. Yes, there will be access to this recording after the class to Vish, who asked that question. Okay, so with that in mind, let's talk about some of my goals. Okay, my goals is to not fall more than 3 minutes behind. I'm going to miss 10 to 14 questions. That's just how it's going to be. I'm not going to get around that. If you're scoring below a 45 on the quant, you should plan to miss 10 to 17 questions, half or more of the questions they give you on the quant section. I'm going to try to make sure I have time to do the questions I know I'm capable of doing, and those ones that I'm going to miss them quickly so that I have time to do the ones that I can get. I know my weaknesses. I'm bad at inequalities, especially when absolute value gets thrown in. Hard combinatoric questions, whose weakness is that not? Word problems that have big, ugly numbers, I don't particularly like. And I want to always remain unperturbed. If something flushes me, I want to just shake it off, move on. Okay. And I want to catch myself from making stupid mistakes. That's one thing I want to do is make sure that I don't make too many silly mistakes. That's what really hurts a GMAT score. So what I want you to look for as I do this is the decisions I'm making and why. How am I deciding what to do, when to do it? When am I deciding to bail? That kind of thing. What strategies do I pick to do a problem? Why? What am I seeing in the problem that's making me pick that strategy? How often I get confused and flustered? It's going to happen a lot. Ricardo, I do hope to do this for verbal at some point as well, yes. I'm going to get confused and flustered, and I'm just going to have to guess. That's going to happen. Notice when I stop myself from going too fast. When I say, like, that was a little fast, let me slow down, let me check that work. I'll do that several times, okay? A little healthy self-doubt goes a long way on the GMAT. What amount of time I spend thinking about a problem versus working on a problem, okay? It's a big, big split. A lot of people just jump into work without actually thinking through what the problem is, and how often I check my pacing when I need to, okay? So with that said, let us switch the GMAT, okay? This will, as I mentioned also in my email, this will probably go over an hour. The section itself is 62 minutes, and then I'm gonna look and see how much I missed and see what my scores are and whatnot. I'm gonna click through the rest of the test, so you're gonna see how I did, okay? So that will take a little bit more time. So with that said, let me share my desktop and we will begin. Okay. Also, I will not be able to see chat during this time. I will answer questions at the end, but I will not be able to be chatting while trying to do this test. It's just miserable enough just to take the test. Okay. So let me get this window set up to the correct size. I'm going to need it to be more or less bigger than that. Leave a little white room on the right. Okay, this hopefully will work. I might have to resize up front, but let's just get this pony kit. I want to make sure I am recording this time. Okay, recording is happening. And here, well, not quite. Holding, getting to the right dang page. This program can be a little bit frustrating to navigate. Those of you that have done some studying already might know that. Where is the dang thing? All right, hold. This is what happened last time. This is when I stopped recording last time and then forgot to start. And I'm not going to do that this time. So for those of you that are watching, I apologize for the delay. But I just want to make sure I don't undo the very reason I'm trying to do this thing again. Okay. Access official starting. Oh my gosh. There we go. Okay, that was easy enough, right? Oof, okay. Okay, introduction, yeah, a lot of instructions. Good, I'm good. I get it. We can select schools, that's cool. Differences and stuff, that's fine. This is all stuff you should be very well aware of by the time you take the test. I'm gonna go through it relatively quickly. Yeah, testing the rules, okay, confidential. Okay, so I get to pick the order now. I'm gonna start with quantitative, just because that's the section we're gonna do. Okay. Yeah, that's the efficiency instructions. Okay, here we go. Okay. True to form. We seem to be great. Okay. I am going to pause the recording. And we should be back with the recording. Okay, the exam is paused. I'm just going to go from here. I might not have that fancy white page to the right, but I'm going to make sure that we can get this. And go. Okay. Student either likes or dislikes llama. Okay, so this is an overlapping set question. So in overlapping set questions, I draw my overlapping set box. It's not very pretty in a word text. So I have lima beans, they like lima beans or they don't like lima beans, and they like Brussels sprouts or they don't like Brussels sprouts. Of all these students, 2/3 like lima beans. Okay, so here's the total students, and 2/3 of those students like lima beans. Okay, dislike lima beans. Oh no, see, that's fun. Read carefully. 2/3 of the students dislike lima beans, and 1/3 like lima beans. Of those who dislike lima beans, so that's here, 3/5 also dislike Brussels sprouts. So that's 3/5 of 2/3. That's going to be 2/5 of the total dislike Brussels sprouts. Excuse me. Also dislike Brussels sprouts. See, Reed, already off to a flustered start. Also dislike Brussels sprouts. Okay, and then I could say 3/5 of 2/3, or 2/5 of 2/3. That'll be 4/15 of the total go here. Okay, how many of the students like Brussels sprouts but dislike lima beans? So I'm looking for like Brussels sprouts but dislike lima beans. And I know there's 120 students at the cafeteria. Okay, so that tells me T, and since I've already filled out all this work, I know that's going to tell me what this number is. So I know statement 1 is sufficient. Statement 2 tells me 40 of the students like lima beans. So that's going to be here. 40 of the students like lima beans. That's going to be here, okay, which gives me, and I know that's 1/3 of the total, so that gives me the total. Okay, so both of these are sufficient. Let me just double check that. I did that really sloppy, guys. But I feel pretty good now that I've oriented myself. 2/3 like lima beans, dislike lima beans, 1/3 like lima beans, 3/5 also dislike Brussels sprouts. That's here. That tells me something. I can get this. Once I know the total, I know everything. Okay, yeah, I feel pretty good about D. Okay, so I'm going to clear my stuff and choose D. Off to a little rocky start. That's always fun. Okay, I got to get that on my way so I can see the time. Susan drove at an average speed of 30 miles an hour for the first 30 miles of the trip. Okay, so this is a multi-leg journey problem. I'm going to draw a table that looks similar but is actually different. We have distance, rate, and time. Distance equals rate times time. 30 miles per hour for the first hour. For the first 30 miles of a trip. So that's 1 hour. And an average speed of 60 miles an hour for the remaining 30 miles of the trip. So that's a 60-mile trip. 30 miles an hour, 30 miles at 60 miles an hour is going to be a half hour. Okay, so she made no stops, and so that's 3/2 of an hour, and I want to know her speed in miles an hour of the average trip. So well, 60 over 2/3, which is 40. So I'm going to say 40. Feel pretty good about that. I got to get my face out of here. Okay. A used car dealer sold one car at a profit of 25%. Dealer's purchase price for the car. I think I've seen this problem before, but it's been a while, and I definitely know how to do it. Okay, so sold one car at 25% the purchase price, 25% profit of the purchase price, and another car at a 20% loss. So that's 80% of another purchase price. And we're told that each car was $20,000. What was the dealer's total profit or loss of the two transactions combined? Okay, so a 25% increase to $20,000, I know that's 16,000 because I'm very fluid with my percentages. That's one thing I'm very good at. 80% decrease, so that'll be a $25,000 car originally, losing 20% of that, which will be 1/5, would get me to $20,000. Yes, okay, so this one is a plus 4,000, and this one is a minus 5,000. So in overall, I lost $1,000. Do I feel pretty good about that? I feel pretty good about that. 25% increase, 20% of the, yeah, okay. I feel pretty good about that. So I want to say a $1,000 loss. Okay, in a stack of boards at a young bar, the 20th board from the stack is immediately below the 16th. counting from the bottom of the stack. How many boards are in the stack? I haven't seen this problem, but I've seen ones like it, and it has to do with how much overlap there is. The GMAT loves overlap and like understanding overlap and not double counting stuff. So I have 20th board from the top. So here's my 20 boards. And I'm told that that 20th board from the stack is immediately below the 16th board from the bottom. Okay, so here I'm gonna kind of draw a little picture here. This is, I might have seen this one before, I can't remember. But I'm gonna draw a different stack here. This is, okay, so this is the 16th stack from the bottom. And I wanna know how many are in the stack. Well, I count 20 here, and then these two overlapped. So that takes this to 14, so I say 34. I feel pretty good about that. I was careful there. Watch me miss it, that'll be fun. Okay, the number 75 can be written as the square of three different, can be written as the sum of the squares of three different positive integers. What is the sum of these three integers? The number 75 can be written as the sum of the squares. Okay, so I'm adding three perfect squares to get to 75. Okay. Are they positive? Yes, they are positive numbers, so I can't use 0. What is the sum of these three integers? Well, okay, I'm pretty narrow, like, okay, let's just list some perfect squares. 1 and 4, that's 9, 16, 25. See, I get pretty big pretty quickly. 36, 49, and then 8 squared is 64, I guess. I mean, I don't think I can get to 11. So I can't have numbers bigger than this. So these are the only ones I can have. So I got to find three that add up, three of these that add up to 75. 25, 1, and 49. Those look nice. So that's 1 squared, 5 squared, and 7 squared, which gets me to 13, which I see there. Do I feel good about this? I'm a little bit ahead of pace, so I can make sure I get this right. 75 is sum of three positive squares of three positive integers. There are the squares of positive integers. They add to 75. 49 plus 1 is 50, plus 75 is 75. And 1 plus 5 is 6. Okay, yeah, I feel good about 13. Notice how careful I am. I double check myself. Okay, so good. So I'm a little bit ahead of pace. That's fine. The rate of a certain chemical reaction is proportional to the square of the concentration of chemical A present. Whoa, I hate this already. The rate of a certain chemical reaction is directly proportional to this. Okay, so I'm looking at this first part. Directly proportional. So directly proportional means is something goes up, something else goes up. So here's the amount of A present, and I'm told that the rate is directly proportional to that. So the area squared, square of the concentration to the rate is a constant. I know that's some constant. That's what direct proportion means. Inversely proportional to the concentration of chemical B present. Okay, so that's when one goes up, the other goes down. That often looks like this. So B times the rate, concentration of B is some other constant, K2. If the concentration of B is increased by 100%, so we double B, which of the following is closest to percent change in the concentration of chemical A required to keep the thing unchanged? Great. Okay. So I think I'm gonna have BR over A. Let's do this, because this A squared, this should be some overall constant. That's the overall combination of these things where I combine my two proportionalities, okay? So I double B, so I say this times 2. Concentration of B is increased by 100%. Which of the following is closest to percent change that A is required to keep the reaction rate unchanged? So I need to, in order to keep the rate unchanged, I need this to end up canceling out that times 2. So I need a 2 down here. Well, that means I'm gonna get this, I don't know how I feel about this, guys. I'm gonna go through this quickly because I don't feel very confident about it. I'm gonna square the square root of 2. So I'm gonna say I need to double my, or increase my concentration of A by root 2. That's approximately a 40% increase, because I know root 2 is 1.4. So I'm going to guess it's a 40% increase. I don't feel great about it. I feel okay about it. That's how I feel about this one, but I want to just get out of here because black. Hate that. If the terms of sequence. Okay. So it's just a sequence. I don't know anything else about it. Just a list of numbers, and I want to know how many numbers there are in the list. I don't know anything about the sequence. Okay, so the sum of the numbers in the list is 3124. Okay, nothing. There's no way that's sufficient, right? No. If I know the average of the in terms is 4. Okay, but okay. It seems like the answer is going to be C. That seems too easy. But I think that's what it is. Because if I know the sum and I know the average, I know how many numbers there are. What is the value of n? I think it's C. God, do I feel, am I making a silly mistake? What is the value of n? Yeah, I'm going to say C. That one seemed a little easy, but I feel pretty good about it. Oh, inequalities. Okay, so we might be in my weak zone. Is m plus z positive? That's what I don't know. Is m plus z greater than 0? Okay, statement 1, if I rephrase it, tells me m is greater than 3z. Well, I could have something like 1 million and like I could very easily make this positive. The question is, can I make it negative? And let's say I have like negative 1 is greater than 3 times negative 100. That's definitely true. And negative 1 plus negative 100 is not greater than 0. So I could have positive, I could have negative. The answer is, I'm basically testing cases now, guys. Okay. Basically testing cases. Statement 2 tells me 4z, if I rephrase it, 4z is greater than m. Again, very easy to imagine a positive sum here, because I could just have 101. That's easy. The question is, can I make it negative? And if I have 4 times negative 1, that's going to be greater than negative 100. Remember, guys, with inequalities and negatives, it's very counterintuitive. You know, it's like negative 4 doesn't feel greater than negative 100, but it is. So I can negative 1 plus negative 100. Okay, so I can also make those. So I'm going to say it's not B. So the question is now if I bring them together. I don't feel like it's going to be. If I line these up, I know the GMAT likes to do this. If I line up m minus 3z is greater than 0, and I do some rearranging and I say negative m plus 4z is greater than 0, and I add these together, I get z is greater than 0. So I know z is positive from the two statements together. Okay, can I make m? What do I know about m if z is positive? Well, I know m is bigger than 3 times a positive number. I thought this was going to be insufficient, but I think it is sufficient. Because if m is greater than 3 times z, and z is positive, then m must be positive. And the sum of two positives has to be positive. So I'm going to say C. That's a little surprising. I didn't expect that. Okay, if p is an odd integer, what is the remainder when p is divided by 4? Okay, so p is odd. So that actually tells me one thing. I already know there's only 2 options for odd numbers divided by 4. They either have remainder 1 or they have remainder 3. Okay, so I don't know if that helps me or not, but it's a thought that I had. When p is divided by 8, the remainder is 5. Okay, so p could be 13, which when I divide by 4 has remainder 1. When p is divided by 5, so 8. Or p could be 21. Because this has remainder 5 when divided by 8. And when I divide by 4, that's remainder 1 also. Okay, that's not what I was expecting. P is 5 more than a multiple of 8. Well, then it's 5 more than a multiple of 4. So it's got to be remainder 1. Yeah, okay. So if a number is, remainders are what's left over. So it's when it's divided by 8, it has remainder 5. That means it's 5 more than a multiple of 8. Well, that also means it's 5 more than a multiple of 4. And any number that's 5 more than a multiple of 4 is going to have remainder 1. So statement 1 is sufficient. P is the sum of the squares of 2 positive integers. P is the sum of the squares of 2 positive integers. Okay, so I could say 4 plus 9. That's the sum of squares of 2 positive integers. So P could be 13 and have remainder 1. Or P could be 1 plus 9, which is the sum of squares of 2 positive integers. That gives me 10, which has remainder 2. And so I don't think this is sufficient. But I'm a little bit ahead of time. I want to make sure I get this. I feel like I'm going a little fast. 1 plus 9 is 10. Sum of 2 positive, the sum of the squares of 2 positive integers. 4, 9, 13, remainder 1 when divided by 4. 1 plus 9 is 10, remainder 2 when divided by 4. Yeah, I feel pretty good about A. I'm going to go ahead and say A. Okay. I have seen this question before. I do remember it, but I also got it right the first time I did it. I don't remember the exact mechanics, but just know that I've seen this one before. In the figure above, P and Q lie on the circle with center O. What is the value of S? Okay, so just a quick GMAT thing. Here's P, and I want to know S. Here's what S is not. It's not root 3. There's just no way it's root 3. You have to know that the test is harder than that. This is not a mirror image. It looks like a mirror image. It is a lie. What we want to do here, I'm going to draw a little bit bigger. This is going to be fun. Geometry with this mouse setup. Okay, so the right angle here, this is at negative root 3. Negative root 3 in geometry questions really puts me into 30, 60, 90 triangles. Okay, it's one of the proportions of a 30, 60, 90 triangle side. And so negative 3, 1 means that this thing, since the y value is 1, that tells me that this is 1. And it tells me that this length is root 3. And this is a 30, 60, 90 triangle. That's what I know now. I do know that these are the same because it's a circle. So I have 1 root 3. This is going to be 2. So it's a circle with radius 2. I know that, where's the short side? This is 30 degrees. It doesn't look like 30 degrees, but it's opposite the shorter side over here. So this must be 60 degrees. And so that means here 30 plus 90 is 120. This has to be 60 degrees. And so I have another 30, 60, 90 triangle over here. And the hypotenuse is 2, so the short side is 1, and the height is root 3. So they just kind of flip sides. So I know S is the x coordinate, so S is 1. Do I feel good about that? I do. I feel pretty good about that. Feel good about the drawing. Feel good about the 30, 60, 90s. Yep, okay. Notice I'm just being careful. I don't want to go too quickly and make silly mistakes. I'm also a little bit ahead of pace, still about a minute ahead of pace, so I have the time to do that. During an experiment, some water was removed from each of 6 water tanks. I hate this already. Standard deviation, interesting, not super commonly tested. Standard deviation in the tanks was 10 gallons. What is the standard deviation of the volumes at the end of the experiment? Oh God, okay. So standard deviation measures spread from an average. So the original standard deviation was 10. So one thing I know about standard deviation is that if I change every value in a set, I change the standard deviation like by the same, if I add or subtract the same amount, my standard deviation stays the same. If I multiply every amount by the same percentage change, the standard deviation changes in the same rate. That's just something I know about standard deviation from weird GMAT problems that frankly don't show up very often. So statement 1, for each tank, 30% of the volume of water at the beginning of the experiment was removed. Okay, so everything decreased by 30%, and so I know that decreases the standard deviation by 30%. So statement 1 is sufficient. Okay, notice how I knew what was coming. When you study the GMAT, and this is a rare question type that I don't expect everyone to know, but when you study the GMAT a lot, you get a sense, like you know how they test things. You put yourself in the world of that topic. How do they test this topic? What do they usually ask about this topic? What phenomena about this topic come up? Okay, so A or D is definitely true. So the average, and again, I might be missing all these questions, so we'll see. The average volume of water in the tanks at the end of the experiment was 63 gallons. But I don't know how many gallons it started with. And I don't know what the changes were. I don't know if it was all constant changes or chaotic changes. So I don't think statement 2 is correct. I'm going to say A. I feel pretty good about it. Okay. If AX plus B equals 0, is X positive? Well, I just know that AX is greater than negative B. I guess, I don't know. Or equals to negative B. Equals negative B. Is X greater than 0? I see inequality, so I'm sad. A plus B is positive, A minus B is positive. Let's start with this one. So both of those are, not both of those are positive, the sum is positive. AX equals negative B, and the sum is positive. So I could have like 2, negative 1 equals negative 2, because 2 plus 2 is positive, and then X is not greater than 0. Okay, I could also do, I feel like I'm wasting time, but I'm so cautious on inequalities, I'm terrible at them. But I could also do something like negative 4 times a positive 1 equals, is this A is negative 4 equals negative positive 4. Wait, hold up. I broke my own rule. No, I didn't. No, I'm okay. I'm okay. But negative 4 plus 4 is not greater than 0, so I can't use those numbers. What if I do negative 4 times 2 equals negative 8? Okay, so B is 8, A is negative 4. Those add to a positive number. X is positive, so A and D are out. Testing cases, guys. Following rules, testing cases. Probably not the most efficient way. But, okay, so now A, I'm told A is greater than B in statement 2. That's great. A is greater than B. And A times X equals the opposite of B. Can I use any cases that I've already used? 2 and 2, I can't do that. I can't use negative 4 and 8. What could I use 4 and negative 8? I could use 4 times 2 equals the opposite of 8. I could do that, and that follows the rule. So in this case, X is positive. Can X be negative if A is more than B? Can X be negative? I can feel my brain slowing down, by the way. I can actually feel my reasoning getting cruddy. I hate these. Can X be negative? Or 0, can X be 0? X could be 0. There's nothing that says it can't. So if I have, and A has to be greater than B, so I could do 4 times 0 equals negative whatever, 1. No, it doesn't even equals, no, wait, I lied. That's equal 0, duh. So could B be 0? Is there any reason B can't be 0? No. Okay, so here X equals 0, which is not more than 0. So I know statement 2 is not sufficient. I say that, I don't feel great about this one. I know the 2 together, if I add them up, I'm gonna get A is positive. Which I think E. I'm gonna choose E. I feel like I'm wasting time on this question. This is my weakness. I don't want to spend time on my weakness. Okay, here we have a triangle. The measure of PRS is how many degrees greater than the measure of PQR? Okay, I'm gonna draw a bigger shape because I need it. This. And I wanna know basically angle X and Y, and I wanna know how much bigger, I wanna know X minus Y. That's what I'm looking for. Okay. I've seen this one before, but it's been a long, long time. How many degrees? Okay, so the measure of QPR, that's this thing is 30. Gross, okay. So it feels insufficient, but I don't think it is. This is one, I feel like I'm getting trapped here because this means x equals 30 plus y. This is, yeah, so this is the exterior angle theorem. I know x is 30 plus y because this angle P is supplementary to x in the same way that P is supplementary to y plus 30. So x equals 30 plus y. Let's call, I don't know. I'm gonna test cases again. This is silly, but let's say this is 40. So I have 90 plus 40 is 130 plus 50 here. So x is 50. That would mean P is 130. That would mean y is 20. So 50 minus 20 is 30. 50, 90, wait. How did I do that? That was terrible math. Well, 90 plus 40 is 130. Yeah, okay, 50. So x equals 30, yes. Y is 20, x is 50. Yes, so x minus y is 30. Okay, then if I change to, let's say not 40, let's say it's 20. Then x would be 70. Y would be 40, and that's 30 again. Yeah, so this one is definitely sufficient. It doesn't look sufficient, but it is. It's one of those sneaky games. I'm gonna clear my map just because that's needs to be cleared. Okay, then we have this right here. We know that the sum of PQR, that's what I called Y earlier. So I know Y plus PRQ is 150. That was X. So Y plus X is 150. Is that right? No, this is 150. This angle, P plus Y, is 150. Okay. How am I doing on time? Question 13. I'm starting to slip behind. I need to catch up. I need to just bail on this. I don't want to, but I need to. So I'm going to say, I know statement 1 is sufficient. How did I feel about, I think statement 1. I don't feel great about statement 2. A total guess. Between A and D. When 1,000 children were inoculated with the vaccine, some got inflammation on the side and some developed a fever. How many? Okay, so this is another overlapping set. I have inflammation and not inflammation. I have fever and no fever. And then I have some totals. Boom, 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 boom. Okay, and I know there's 1,000 people, 1,000 kids getting this vaccine. This is not great for the anti-vaxxer debate. Bad problem, bad. 800 children develop neither inflammation nor fever. So this is the 880 who are here. And what do I want to know? I didn't even specify the question. How many children developed inflammation but not a fever? So this is what I want, inflammation but not a fever. And I don't know anything else up front. Okay, so 880, that does not tell me that because I don't have enough. It tells me 20 children developed a fever. Is that true? Is that really not enough? Yeah, it's not, because I could have 10 or I could have 3. Okay, yeah, statement 1 is not enough. Notice I checked it, I just wanted to make sure. 20 children developed a fever. Okay, so now I'm down to statement 2, 20 children developed a fever. That means that 880 did not develop a fever. I don't know this right now. I have to pretend I've forgotten that. So I don't know. Okay, but together, it's 0. That seems too easy. I don't feel great about that. But I am falling a little bit behind on time. So I'm going to say C. Ugh. Whatever. Next question. Positive K has 2 prime factors, 3 and 7. So 3 times 7. I don't know how many of each. Okay, it could be 3 squared or 7 to the 5th, who knows. K has a total of 6 positive factors, including 1 in K. What is the value of K? Okay. Positive K has 2 prime factors. 3 and 7. K has 6 total factors, including 1 and K. What? Okay, so this is using a somewhat obscure rule where I can figure out how many factors a number has based on the number of prime factors it has. And I know that that rule is you add 1 to the exponents of the prime factors and multiply them together, and I should get, in this case, 6. So it seems like it's either going to be 2 times 3 or 3 times 2, because I can't have 6 times 1. So it's either 2 times 3 or 3 times 2, okay? Which means either n is 1 and k is 2, or n is 2 and k is 1. And the question is which is which? Okay, statement 1 tells me 3 squared is a factor of k. Well, that tells me that this has to be 2. I have to have a 2 for n. So that immediately puts me into this world. So I am actually already done. I know that statement 1 is sufficient. And statement 2 looks very similar. It tells me 7 squared is not a factor of k. That means I can't have 2 7s. I have to only have 1 7, which again puts me into the same world. So the answer here is D. I want you all to think about how much time I spent on the problem and how much time I spent on the statements there, because the answer is almost all the time on the question and hardly any time on the statements. Not uncommon to see. And of course, I might miss that question, and you can all laugh at me. If k consists of 12 consecutive integers. Okay, so 12 consecutive integers. So consecutive integers do weird things. I have to keep that in mind. There's averages are the medians that come into play. There are some remainder games that come into play. So I just know what happens when I see 12 consecutive integers. If -4 is the least integer in that list, what is the range of the positive integers in list K? 12 consecutive integers. Okay, so I have -4 is the first integer. This isn't the game I thought was going to be played, for the record. Now, do I add 12? See, this is the thing. It says 12 consecutive integers, but I don't think I add 12 to go -4 to 8. Because 8 minus -4 plus 1 is actually 13 numbers. It's actually, I go to 7, sneaky, sneaky GMAT. Counting how many integers there are is not the same thing as counting how many gaps between integers there are. With 11 items, there are, with 12 items, there are 11 spacings. Similarly, just think about one number. If I go from 1 to 2, there's only one gap in between. I don't add 2 to go from 1 to 2. I only add 1. Tricky. And to go to 3, I only add 2. So that's the game that's being played here. So I only care about the range of the positive integers, which will be 1 to 7. That range is 6. Tricky, tricky, GMAT. Never seen that problem before. I like it. When a certain tree was first planted, it was 4 feet tall. So we're going to change either by percentage or by adding the same height every year. The height of the tree increased by a constant amount each year for 6 years. Okay, so I have 4 plus for the next 6 years. So 6 times the growth rate. That's just, for the next 6 years. When a certain tree is planted, it's 4 feet tall for the next 6 years. At the end of the 6th year, so in the first year, yeah, okay, good. The tree, just notice how much I'm thinking about what the hell I just did, because I want to make sure I did it right. If at the end of the 6th year, so that's going to be 4 plus 6x, the tree was 1/5 taller than it was, okay, so 4 plus 6x is 1/5 taller, that's multiplying by 6 over 5, how tall it was at the 4th year. Okay, and that's 4 plus 4x. That's how tall it is at the end of the 4th year, where x is the change. So I have 4 plus 6x equals, I don't like this next part, 24, you know what, screw it, I'm gonna multiply everything by 5. 20 plus 30x equals, got rid of the 5, it's going to be 6 times 4 is 24 plus 24x. Notice that arithmetic trick, or that algebraic trick I just did, I didn't like fractions. I'm going to subtract the 20 and get 4 on the right side. I'm going to subtract the 24 and get 6x, so I'm going to say x is 2/3. Are there any units? I'm going to be pissed if there's a unit switch and I didn't see it. constant amount, how many feet each year? 1/5 taller, 4 feet tall. Okay, yeah, so it's all feet, so 2/3 is correct, or I think it's correct. We'll find out later. How am I doing on time? I'm doing okay. So, okay, this is fun. So whenever I see something like adding exponents with the same base, I can't really use like my nice exponent rules, but I can factor stuff out. And I tend to want to factor out the smallest possible value. And the smallest possible value of those two is actually 2 to the x minus 2. I guess it's assuming x is positive, but it's probably going to be. Using my exponent rules, I know that I'm left with 2 squared in the first position. If I refactor that, I get 2 to the x, because 2 to the x minus 2 times 2 to the 2, I add the exponents, I'm left with x. Minus 1 is here. And I'm told that equals 3 times 2 to the 13th. Okay, well, this is going to be 3, 4 minus, that's 3 times 2 to the x minus 2 equals 3 times 2 to the 13th. Well, the 3's divide out, and I get x minus 2 equals 13, so x is 15. I'll just answer that. Okay, very similar question, apparently. What is the greatest prime factor of this hellish looking thing? This reminds me directly of a question in the book, of the GMAT book that I teach many times, 3 to the 8th minus 2 to the 8th. Anyone who's studied a lot might know that. It's a little bit different because the exponents don't work out nicely, but what I can do is I can factor out a 4 of that. No, wait, let's turn, okay, hold up. Let's turn these all to 2. That's what I want to do. 4 is 2 squared, so 4 to the 17th is 2 to the 34, and then minus 2 to the 28th. Okay, so this is much, I say much better. These are still really big numbers. Huh. Okay, but now I can use a 2 to the 17th plus 2 to the 14th times 2 to the 17th minus 2 to the 14th. And you're like, Reed, why, dear God? Well, now I'm going to factor out 2 to the 14th from this first one. I'm going to be left with 2 cubed plus 1. That's much easier to manage. I'm going to factor out 2 to the 14th here, and I'm going to be left with 2 cubed minus 1. And so I'm going to have 2 to the 14th times 2, or times 2 to the 14th, so really 2 to the 28th. So I have a lot of 2's in this problem, times 2 cubed plus 1, that's 9. That's 3 squared, times 2 cubed minus 1, that's 7. My handwriting almost screwed me up there because this is a cube, not a square. So the highest prime factor here, that's a 3. So the highest prime factor is a 7. So I'm going to say 7. Feel pretty good about it. Pretty good on time, not terrible. Every integer k from 1 to 10 inclusive, the kth term of a sequence. Okay, so I'm dealing with a sequence here, -1 to the k plus 1. So I already know right here what this does. This changes numbers from negative to positive as I increase k. Because -1 either is, -1 to an exponent is either 1 or -1. Okay, so I'm dealing with stuff like that. Okay, then I have 1 over 2 to the k. That's powers of 1/2. And so as k gets bigger and bigger, this gets smaller and smaller. It's flipping signs. Okay, and now I'm adding stuff together. I'm adding the sum of the first 10 terms of the sequence. Then t is, but my answer choices are not actual numbers. I need not worry about the actual numbers in this set. So let's just do the first one. When k is 1, I get -1 squared, so that's 1, so I get 1/2. Then when k is 2, I get -1, so it's going to be a negative number to the 1/4. Okay. Then when k is 3, I'm back to positive. -1 to the 4 is 1 over 1/8. Okay, so I see I'm just going to then -1/16 and then positive 1/32. I'm just doing that. Okay. And now I'm adding all these together. And I go from 1/2 and I end up at 1/4. And then I add a little bit back to go more than 1/4. And then I subtract a little bit less, but I'm still above 1/4. Then I add a little bit back Did I subtract a little bit less? Okay, so I'm never more than a half. Yeah, I'm certainly not those. Certainly, yeah, it's D. I'm going to end up being between a fourth and a half. I don't care about the actual number. That's not what they asked. Okay. Pretty good on pace. Company plans to assign different identification numbers to its employees. Okay, so I'm already in the mode of combinatorics. 4 digits, 0 to 9 inclusive, except the first digit cannot be 0. How many different, okay, so this is just a combinatorics question. I have 9 options for the first number because I can't use 0. Are there any rules about repetition? First digit cannot be 0. How many different, no, okay, so it's 9 times 10 times 10 times 10, 9,000. Right? Oh no, God, see? Ha 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 ha. Different digits. That's fun. So I choose something for the first digit. Man, see, this is why you double check yourself, even when you feel confident. And then I don't have 10 choices. I only have 9 choices because whichever digit I chose here, I can't choose again. But I can bring 0 into the fold. So I have 9 times 9. Then it's times 8. I have 8 choices times 7. Okay, I feel better about this. So it's 81 times 56. And I don't need to do the math because this is going to end in a 6, whatever this number is. And there's only one option, so I'm going to say B. Okay, that's the only number that ends in a 6. Do I feel good about it? I guess so. Watch me miss it. Okay, we have a shape, it's a conveyor belt. Figure above, I've seen this problem before. It's a, I don't remember the specifics, but I've seen it before. I felt pretty good about it when I saw it. As shown in the figure above, a thin conveyor belt 15 feet long is drawn tightly around 2 circular wheels, each with 1 foot diameter. Okay, so I have this like weird thing. I have 1 foot diameter of these. Okay, what is the distance between the centers of the wheels? I want this distance. Okay. So circumference is going to come into play. The whole thing is 15 units, 15 feet. So that's like the whole thing around is 15 units. If I subtract that semicircle, I have a nice little rectangle. Okay, oh, and there's 2 semicircles, so I can subtract just a full circle. Okay, which diameter, okay, so the circumference of one circle is going to be 1 times pi, diameter times pi. I have half of that circumference here, half of that circumference here. So what is left, what is going to be in green, is going to be 15 minus pi. Feel pretty good about that. But then that's these 2 things. I only want one of them because I only want the distance from center to center. So I need to divide by 2. So I say A. Do I feel good about that? Distance in feet from the centers of the 2 wheels. 2 circular wheels, 1 foot. I do feel pretty good about that. Yeah. Okay. On a certain one-day seminar, okay, consisted of a morning session and an afternoon session. Each of the 128 people attending the seminar attended at least one of the 2. How many okay, so it's another overlapping set. It's a lot for this one test, but whatever. We have the morning session, and they didn't attend the morning session, and we have an afternoon session, and we have didn't attend an afternoon session, and we have some totals. And I actually know up front there's 128 people total. And I also know, sneaky, 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 that every one of them attended at least one of the 2. So I already know that this is 0. Nobody attended none of them. Okay, so I don't have to, so I actually, they give us 2 numbers there. That's sneaky. How many of the people attended only the morning session? So I want the morning and not the afternoon. So I want this box. 3/4 attended both, 3/4 of everybody. Okay, so that's 3/4 of 128 is going to be like 32. So I know 32 people attended both. No, 3/4. So it's 32, 64, 96. So 96 attended both. But I don't know any of the other designators. I don't think there's any way to tell, unless I'm missing a piece of information. At least one of the two. How many people attended the morning session only? Yeah, I think we're pretty good. So I'm going to say that statement 1 is not sufficient. Statement 2 tells me 7/8 of the people attended the afternoon session. So total afternoon sessions was 7/8 of the people. I don't know what 7/8 of 128 is, but who cares? This is going to, so this is the afternoon. So this is 7/8 of the total attended this. That means 1/8 of the total attended this, but sneaky, sneaky, since 0 attended neither, I know that 1/8 of the total attended the morning, but not the afternoon. What? That didn't feel good. 7/8 of the people attended the afternoon session. So here's the afternoon session, 7/8. This is unexpected. It's sufficient, I think, because then 1/8 did not attend the afternoon. And since nobody attended, yeah, I don't feel good about it. Like, I don't feel good, but the table told me, and I'm going to trust the table. We'll see how that ends up, but for the sake of time, I'm moving on. Last month, 15 homes were sold in X. The average was 150. Okay, 15 homes, that's, okay, too many to draw. The median, okay, so I know one of the homes was 130. I have 15 slots, and the 8th, and 1 through 7, 8. Yeah, the median will be the 8th house. Which of the following statements must be true? So the average is 150. Okay, at least one of the homes is sold for more than $165. I don't think there's any way I know that's true. I know that the median brings me down 20 from the average. And if every one is the same, if all of them are 130, they bring down 20. So that'd be negative 160. So I'd be 160 short of the average here. How could I divide that between 7 houses? That would be, interesting. What I'm doing right now is a balanced average approach. I'm imagining if every house is the median, that's left of the median, because that's as big as those houses can be. Does that mean one of the houses is still more than $165,000? 9, 10, 11, 12, 13, 14, 15. 1, 2, 3, 4, 6. Yeah, okay, so the 8th house is the median. Short 160. What's 160 divided by 7? That's going to be 140. That's going to be 20 plus 140 over 7 plus 20 over 7. No, because every house, not quite. It's almost true, but it's not necessarily true. Statement 1 is not necessarily true. If every house is basically 20,000 and is $22,000 more, I'm okay, and that's no houses that are above 165. Oh, I'm not even close, because I was thinking 155, so that's silly. At least one of the houses was sold for more than 130 and less than 150. That is definitely true. No, is that true? Haha, see, Reed, you're just so silly. Basically, does there have to be a price in between the two? Well, here's one thing I know. I've gotten rid of statement 1, and I feel kind of bad about that because it gets rid of a lot of answers. That might have been too convenient, but I got to move on. Time is part of the game. So either 2 or 3 is true. I just built a set where none of the homes sold for less than 130. I just built that set. So I don't think 3 has to be true. So if that's true, I just say 2. And I don't know why, but I feel pretty good about my reasoning. We're going to check that one. I'm going to see how I did on that question, but I feel pretty good about that one, actually. I'll miss it. That's how it works. If x is not 0, then root x over x is, well, root x squared, it's not necessarily x. We have to be careful here because x could be negative. It's really the absolute value of x. And so it's really the absolute value of x. So this one I make up pretty quick. And that's just based on the fact that I have to remember that negative numbers squared go positive. And so that square root of an x squared is not necessarily x. The trap answer here is 1, right? How do I know this? Because I've seen this trap before on a problem. Not very often. It's not something I've seen a lot, but I've seen it a few times, and so I'm just on the lookout for it. Okay, doing pretty good on pace. If the xy plane does the line y equals, okay, so contain the point rs. Well, if I plug in rs into that equation, I get s equals 3r plus 2. And so I want to know if s equals 3r plus 2. That's really the question. This tells me 3r plus 2 minus s times 4r plus 9 minus s is 0. So that means either, if I take this one, that means either s equals 3r plus 2, or if I look at the second one, it means s equals 4r plus 9. So I don't know which is which, so I don't think statement 1 is sufficient. Statement 2 tells me that either, because these multiply to 0, right? So I know one of them has to equal 0. And if they equal 0, then s either equals 4r minus 6, or, using the other one, it equals 3r plus 2. It's either one or the other. Okay, now if I combine the two, because I know they're not sufficient alone, because each one gives me 2 different possibilities. But if I combine the two, the only one that's consistent is 3r plus 2. This one goes out and this one goes out, so the answer is C. How many different prime numbers are factors of positive integer n? Okay, how many different prime factors? So I just want to know something about the divisibility of n. 4 different prime numbers are factors of 2n. Okay, so I know that 2n divides into 4 prime factors. One of them is going to be 2. So I have 2 times a prime times a prime times a prime. And I don't, here's a lesson for everybody. Last time I did this very exercise when I messed up the recording, there was a question that had a very similar trap like this, and I missed it. It's only one of the questions I've seen. Here's the trap right now, is that I don't know if n has a 2 or not. Let me think about that. Yes, because I don't know how many 2's show up in this situation right now. Okay, there definitely is a 2 because there's a 2 here, but n might have some 2's as well. This is what I forgot last time. I forgot that n might have that same prime factor. It wasn't the exact same question at all, but it was a very similar trap. And so the game now is like, your thought is like, oh, there must be 3 primes for n, but it could be 4 primes, one of them being 2. So I could have p, 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 and p, or I could have 2 p, p, and p, and then this 2 joins up with this 2 there. So, excuse me, very sneaky. Statement 1 is not sufficient. I fell for that trap last time. I'm not going to fall for it again. That's called learning. So statement 1 is not sufficient. Statement 2, 4 different prime numbers are factors of n squared. So that tells me there are 4 prime factors of n. Yeah. Because if I take n and I square it, I don't get any new prime factors. It's just that I square all the prime factors. So I'm going to say statement 2. Sneaky, sneaky, GMAT. Okay. How are we doing on time? Doing okay. For which of the following functions? Oh, okay. So is f of a plus b equal to f of a plus f of b? So this is saying if I add 2 numbers and run them through a function, do I get the same thing as if I run the function independently and then add them? One way to do this is testing numbers. I'm running out of time. I have seen this question before. I don't remember the answer, but I'm going to do a conceptual understanding of this, which is kind of a GMAT expert thing to do. But if I add two numbers and square them, that's not the same thing as squaring two numbers and adding them. So I know it's not that. If I add two numbers together and then add one, that's not the same thing as adding one to a number, adding another one to a number, and adding them together. So it's not that. The square root of a sum is not the same as a square root of, is not the same as a sum of square roots. 2 over x. No. So that's saying 2 over a plus b. Does that always equal 2 over a plus 2 over b? And the answer has got to be no. There's just no way that always happens. I think negative 3x feels pretty good, because if that would be negative 3 times a plus b, yeah. Does that equal negative 3 times a plus negative 3 times b? And it does. That does equal that. So I'm going to say E. I have seen that problem before. I don't remember the specifics of it, but okay. Oh dear. Okay, so this is, you might remember, my least favorite type of question. Is the absolute value of x minus y greater than the absolute value of x minus the absolute value of y? So, 3 questions left in 6 minutes. Do I want to spend it on something I know I'm not strong at? I think, if I think about this as distance, this is the distance of x and y, is that greater than the distance from 0 to x? And so the simple case, like there's a kind of a generic simple case where this is true, where it's like, if x is here and y is here and 0 is here. That's always going to work. Similarly, the distance between x and y, if x is here and y is here, yes. So this is when they're going to be equal. They're going to be unequal, the absolute values in this situation. It's going to be if they're on different sides. Like if I have x here, and here's 0, and y is here, then the absolute value of x minus y is going to be way bigger than the absolute value of x minus the absolute value of y. It's also going to happen if y is further away from 0, because if y is further away from 0 than x, then this thing is negative. And so if that's true, then this is definitely going to be true, because x minus y absolute value is going to be positive. So I want to know is, are they on different sides, or is y further away from 0 than x is? Okay, so statement 1 tells me y is less than x. So that could be here, or it could be here, so that's not sufficient. Statement 2 tells me xy is less than 0. So that means that they're on different sides. So I'm going to say B. I don't feel good about this one. I have seen someone think very like it before, pretty similarly actually. I don't know the specifics, but I'm going to say B. It's my weakness. I'm at the end of the test. I got to move on. Of the following integers, which is the closest approximation to root 2 plus root 5 squared? Okay, well, root 2 is 1.4. Root 5 is like 2.2, I think we say. So that's 3.6 squared. So it's got to be less than 16. It's got to be more than 10, right? Yeah. So the question is it 13 or 15? 15 is pretty close to 16. I have a little bit of time. If I know I can get this. So if I square it, I have 2 plus 2 root 10 plus 5. This is just a common quadratic, and I'm foiling it out. So I have 7 plus 2 root 10. Root 10 is a little bit more than 3. So this is basically 13. Yeah, so 13 is correct. I just wanted to double check. Okay, and last but not least, if 0 is less than x is less than y, what is the value of this hellish thing? Okay. Well, quadratics here, 2xy minus y squared, I'm sorry, plus y squared over x squared minus 2xy minus y squared. I know one of the GMAT's favorite games is to split up these quadratics into their component pieces. And as I'm looking, ooh, not quite, is it? So statement 1 tells me x squared plus y squared. If I subtract the 2xy here, this will be fun. I'm left with xy. So this tells me x minus y squared equals xy. So I know that this denominator is x minus y squared. Or I'm sorry, is xy. Does that tell me anything about equals 3xy? Oh, wait, that's silly. I can just substitute in 3xy for those. So that gives me 5xy over 3xy, that's supposed to be plus 3xy over xy. Okay, yeah, so it's 5. Statement 1 is sufficient. Yeah, I can sub in for x squared plus y squared. Okay, that's an annoying thing. Thank you. So statement 1 is sufficient. Statement 2 is not going to be sufficient. So I have a minute left. That's a tricky little game they played where I can substitute in for the quadratic, for the pieces of the quadratic and figure it out. Even though I don't know everything, one of the GMAT's favorite games, I can figure out what I need to know. So I have to click twice at this moment, which is always fun. Okay, so that's it. I'm going to go ahead, stop share for a second. I'm going to click through the rest of the test. What I want to hear from you all right now, thank you for the deep breath, everyone. What I want to hear from you all right now, I want you all to type in the chat as I click through the rest of the test. I want you to type your reflections. What were you noticing? What did you think? What did you consider? What was different from how you would handle things? I don't know, just type your reflections on how I moved through that test. What were you surprised by? What did not surprise you? I gotta say, just for those of you that were here last time, that test felt easier than the one I took last time. After last time, I felt like I was really just beaten down, which goes to show you that the experience of the test kind of varies. You know, sometimes you get lucky, you get some questions that you feel good at. Sometimes you don't get lucky, you get hard questions. Now here's the fun thing, I might end up getting a lower score. I feel much better after this test, but because of the nature of this thing, I might actually end up worse. We'll find out here in a hot second. I'm just clicking through the verbal right now. And then I'm gonna read your comments on what you noticed about my test taking. What things jumped out at you. It's kind of frustrating because I have to click through 36 questions. My verbal score is going to be very bad. But that's okay. I do hope to do this at some point. I'll just hit reset the exams and I'll retake this and I'll do the verbal section. I'll do a similar game. It'll be a little bit tougher because there's not as much scratch work, or really there is scratch work, but I can't show it. There's no way I can do a passage map in this format here, or a critical reasoning work in this format. What I can do is really highlight sentences. That'll be helpful. Almost done with the verbal, then I'll just have to click through some integrated reasoning. Okay, integrated reasoning, yeah, there's a break, next. Okay, almost done, friends. Okay. A lot of two-part questions on this integrated reasoning, that's strange. Okay, boom, boom. If anyone is ever wondering, if anyone ever takes a test and they're trying to see their score, you do have to click through. If you only want to do a section, you do have to click through the rest. Let's see. Okay, getting close, I promise. 2, 3. Okay, and then we have to say the essay. I'm gonna write a really good essay. This is an essay, and submit. Okay. Okay, so This is annoying. So I'm just going to read your responses. So here's what I see. I see impulse to get to the point, clock is ticking, never got lost, are still sharp, superb. How you dealt with time, yeah. Comprehending questions, breaking it down, self-control, thank you. Joshua, don't, this was freakishly, this was not the experience that I usually have when taking the test. And I just saw the results. And so this is kind of ruining the point that I like from these. Knew what topic was being tested. Yeah, that's really huge. Okay. You can literally just flip through a book and be like, what's being tested here? What's the topic? And you don't even have to do the question. You just like lay out what's being tested here. How much time you took to process the questions before you tackled answers. Yes, processing is what the test is. Okay. Knew what topic was being tested. Smart numbers are much better than a theoretical approach in certain questions for sure. Speed at which you answer the questions. That's partially because I've seen some of those questions before. That's partially because I teach this for a living. Breaking it down, yep. Dealt with time, never got lost. Double checking and catching errors. Yeah, I caught several errors that I made that would have hurt. Spent more time on questions versus statements for huge. Yep, but had to rush to get to the point. More time on question stem rather than answer choices. Yep. There are 3 overlapping sets at you. This seems like for someone like you. Yes, Foxy Daddy, you're exactly right. There were 3 questions that were overlapping sets. I feel pretty good about them, especially when there's only 2, because that table is such a strong tool. And that's actually a question that's not really in the main test as frequently as it used to be. So I got kind of lucky on this one. And that happens, especially at higher scores. You know, if you get a few questions that are in your wheelhouse, then otherwise you're going to get maybe a better score. And last time I did this, I got a 50, which was the highest score I ever gotten. I think I beat it this time. But it's partially luck. You know, last time I felt like I got my butt kicked. People who saw it, I was like, ugh, at the end. And this time I feel pretty okay. It was pretty easy for me, because I studied this stuff. I teach this stuff. But it's not always that easy. Again, I feel kind of bad because I stepped on my point a little bit. You know, good reasoning has ways to trip you up for sure. Checking for the last digit instead of doing the math out for sure. Ability to simplify the problems. Didn't have to do calculations. Yeah, I saved calculation work because who needs it? Thought out loud the properties first. Yeah, I did do that. That's a handy thing to do. Just frame yourself. How does the GMAT test this stuff? Okay. You didn't have to do the calculations. Yeah. Quick to think about the answers, what would not be correct. Yeah, for that one, that's just knowing what the GMAT is and just knowing that that trap has to be there. If you were behind or within the acceptable time, are you calculating? Yeah, I'm doing, for pacing, I'm doing 2 minutes a question. So I just know that every 5 questions is 10 minutes. Okay, so I feel like this is going to step on the point a little bit. No, it didn't. Interesting. Okay, this is very interesting. So I'm going to share my screen. This is fascinating. So the last time I did this, I got a 50. Okay, so I got the same score. It's the highest I've ever gotten. I've never gotten a perfect score on either the official test or an official practice test. I never get a 51. This time I got a 50, okay? And if I look at my responses, here's what's really interesting about this. On the quant, I missed 3. I was obscenely consistent. I've never missed so few before. Here's what's fascinating about this. Okay, here's why this is interesting. The last time I did this exercise, I got a 50 and I missed 11. Here, let me show you. I can actually just show you right here. So notice this one, 3 incorrect. Numbers 9, 13, and 24. Let me go to the first time I did this. I'll show you my other practice test. Here's exam 1, okay? If I view my performance, okay, quant 50, right? Quant 50. Look how many misses. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 11 misses. So I missed 11 questions in one test, got a 50. Felt really bad at the end of that test. That one was hard. I missed 3 questions in this test and got a 50. Go figure, okay? So Charlotte asks, how can I have the same score when there's such a big difference in the number of questions I got wrong? It's a good question. The difference is that the questions on this first test were harder. I missed 11 really, really hard questions. For some reason, the GMAT algorithm this time gave me easier questions, and I missed 3 of them. And so I just happened to, that's just how it went. So Foxy Daddy asked me if I was able to gauge the difficulty of the 11 questions that I missed last time. Yeah, they were hard. They were hard questions. I also made some silly mistakes, including the one that I told you today where I was like, I made this mistake last time. I'm not going to make it again. So there were some that I made silly mistakes, but there were some really, really hard questions on that test. So it's just a weird exam. You know, sometimes you feel like death, you miss 11 questions, you get a 50. Sometimes you feel fine, you miss 3 questions, you get a 50. It's not always about the questions you get right, the amount of questions you get right or wrong. That's not how the test is really graded. And so that's why you just take the questions one at a time. Just take it one at a time, do what you can with it, move on, okay? Let's see which ones I missed. I'm curious about that. What were the 3 questions in Quant that I did not get right? Let's review the incorrect. Okay, so I missed, dang it. I really felt good about that one. Really? Huh, okay. Why is statement 2 sufficient? P is the sum of the squares of 2 positive integers. I did that one. Okay, so I had like 1 plus 9 is 10. That's the remainder is 2 when divided by 4. 4 plus 9 is 13. That's the remainder 1 when divided by 4. What do I? Odd. It says it's an odd integer. There it is. Missed a little detail. P has to be an odd integer. That's it. That's why I missed it. Okay, little detail. Little detail in that question. Oh, okay. So this one I've done before. I know it's tricky. It's a very hard question. It must be D. Yep, it's a tough one. Remember, I had to guess and move on that one. I was just trying to keep time. I didn't want to suck up time on this. I know it's hard. Why fight it? That one I felt pretty good on too. I was hoping I got that one right just because I thought it was a cool moment. Apparently not. 1, really? I'll have to work on it and see what I did wrong. Okay, so 3 questions that I missed. One of them was a silly mistake. One of them I realized I just needed to catch up on time. One of them I knew was hard and tried to do some kind of fancy reasoning and failed. I did feel bad about eliminating 1, if you recall. I knew because it got rid of 3 answers and that just seemed too easy, but I was under time pressure. Okay, so that is it, friends. That is your free GMAT prep hour, twitching the GMAT, watching someone do this test live. I will stick around now to answer the remaining questions. But I hope that just showed you what people worry about when they take this test, when they really know what's going on. What people see, how they react, how they double check, how often I spent time on the questions, how often I double checked when I felt like I was going too fast. How there were times where I mentioned what I had learned from a question I've done before. That's what you want to be studying for. Try to connect questions to previous questions. They're never going to be exactly the same, but you can make that, make a similarity. I am sorry to have only missed 3 questions. That really does step on the point. I was hoping to miss 11 again and show that you get a same, you can get a great score even while missing 11 questions. And you can, as I just showed with my other practice test, but I was hoping you would see that. I hope you would see me struggle a lot more. I just got really lucky this time. That's just how it goes, I guess. Sometimes you're lucky, sometimes you're not. But thank you all for being here. I will see you all at the next GMAT Prep Hour. Have a wonderful evening. Best of luck in your studies.